Yes, so welcome to this talk. I'll be discussing how to get started with the GDS Graph Data Science library for doing graph analytics at massive scale, how to get started with that quite easily, even if you don't have your data inside of the Neo4j ecosystem yet. My name is Adam, and I'm an engineer, as you can see, in the GDS team. So I work mostly with machine learning aspects of that library. Okay, so let's see what we're going to cover today. So first, I'll just briefly go over what the GDS Python client library is, so that you have some idea if you haven't heard of it before. And then we'll go into some details about what kind of data sets you can load very conveniently with this client library, as well as what kind of formats you can load if you have your data somewhere outside of Neo4j and in some formats and you want to load them inside to GDS or Neo4j. Functionality for that, and then if we have time, we'll go over a quick notebook demo of how to import NetworkX graph with this Python client library. So let's get started. Yes, so what is this Python client library? It is a Pythonic surface for GDS, as you might expect. So it looks very similar to the kind of native API to GDS, which is a Cypher procedure API. So it's almost, looks very similar. So it's almost like you can just run the Python interpreter on your GDS Cypher code and it will work. It's very similar. However, it also has some additional convenience functionality that we can add since we have the Python ecosystem to work with. And in today, the aspects of that convenience functionality we'll be discussing is that there are built-in example data sets that you can load very easily into GDS. And you can also import graphs of various formats that you have already, but outside the ecosystem. And the way this works is that it uses this arrow you can see here to the left in the picture. It uses the Apache Arrow protocol for file transfer. There's an Arrow client in this GDS client box, this Python code, and on the GDS side, in the same JVM as the Neo4j, there's an Arrow server that the client communicates with, and through this channel you can do transfer data very, very fast. So that's how it works. And also, once you're in GDS with your data, you can just export it very easily to Neo4j, the database itself as well. So even if you don't have an analytics use case, you can definitely use these import methods. Okay, and yes, it's quite easy to install, as you would imagine, just pip install like any other Python library. So it's easy to get started with. Okay, so now let's go over the different kinds of data sets that you can that the library comes shipped with, that you can just load into Neo4j. So the first category we call the pre-canned data sets, and these are smaller data sets. And in fact, they are kind of built into the Python library artifact you get on your computer when you do pip install Graph Data Science. And for this reason, you don't need any internet access to use them. They're not hosted anywhere remotely or anything like that. Some examples of these are the Cora citation network. So this is very famous paper or famous graph from the literature. It's a homogeneous graph with paper nodes and cites relationships connecting paper nodes if one paper cites the other. We also have an IMDb movie database. It's a heterogeneous graphs with actors, directors, movies, and so on. It can be quite useful to have a heterogeneous graph as well if you want to play around with that. Another one is the Karate Club. It's a very famous example of a social network from the literature. It's quite old now. It's a very small graph, but fun to play around with if you want to do community detection and stuff like that. And there are others as well. And the other kind of category we have for the data sets that the library comes shipped with is the OGB data sets. So these are hosted by the Open Graph benchmark, not by us. And they are really data sets that you would use to benchmark machine learning methods, so machine learning algorithms for the most part, like link property prediction, node property predictions, things like this. They are very popular in the literature, so a lot of papers these days use these data sets in order to get to the leaderboard of these data sets and their accompanying tasks. So it could be useful for if you want to try an algorithm in GDS and compare to the literature. Then you have these datasets to do that. These are fairly large. At least some of them. They have there are some that have like several hundred million relationships and so on, and they are quite diverse. There are many from different domains and so on. They're also realistic. They're based on real data. An example of this is the BioKG, a biomedical knowledge graph, containing things like the nodes like diseases, drugs, proteins, things like this. And the task for that data set is link prediction. So you would try to infer new relationships. For example, if two proteins should interact with each other, if you want to predict if they do that, or if one drug can cure a disease, things like this. Okay, so that's the data sets that we have in this library. You can load them with one method call in Python. But now let's also look at the formats. If you do have your data, you have your own data, but it's not in the Neo4j ecosystem yet. How do you import that? So one way you can do it with this Python client is with the Pandas DataFrames API. So it's been around for a while, so it's quite a straightforward API where you have your nodes and relationships just as big tables. For example, in the node tables, you would have a column for the IDs of the nodes and the column for each property of the nodes, and so on. So it's pretty straightforward. It's been around for a while, as I said, quite successful so far. And this one has the best performance since this kind of table format is what we use under the hood in the arrow import. So there needs to be no like data mangling and so on the client side in order to load these. All right. The next format here that you can use for data import is NetworkX graphs. So NetworkX graphs, they are homogeneous by nature, meaning they only have like one type of nodes, one type of relationships in the graph. But they also have support for properties in a NetworkX format. So what we do is when we import these graphs, we of course import the nodes, the relationships, and the properties, but we also let the user specify like specific properties on the nodes and relationships that sort of tells us what kind of labels nodes and relationships have. So that when you import your kind of homogeneous NetworkX graphs, if you want it to be heterogeneous, you can add these like special properties, and then we will import it as a heterogeneous graph. So you have all the tooling in the Neo4j ecosystem of handling heterogeneous graphs with no labels, or relationship types, and so on. If you had a knowledge graph or something like this, that's very important. And we support all kinds of NetworkX graphs, multi-graph, simple graphs, undirected, directed, and so on. And this import, I think, is really good combined with some NetworkX functionality like file format reading. So NetworkX library has great support for reading a great many different kinds of graph file formats. So what you can do then is just have NetworkX read your graph from whatever file you have, and then you can just import this NetworkX graph directly into GDS with our importer here. And similarly, there's lots of great functionality for doing graph generation of different kinds of random graphs and expander graphs and complete graphs, path graphs, all kinds of stuff in NetworkX. And you can, of course, use this, and then you can just import that generated graph into GDS and do analysis of it there if you wish. And in fact, that's what we're going to do now for a quick notebook demo. So let me switch over tabs. So now we are in my notebook here. Hope you can see. First, what we need to do is to just set up the Graph Data Science library that this is all based on. So what we do then is we import the Graph Data Science object, and then we create the connection by basically providing the credentials to the database and the URI and so on. So I have just a local Neo4j database with GDS installed here. And I also say that I want the database name Neo4j to be targeted through in my calls here. So we're just going to do that. So now that is set up, we'll scroll down to the NetworkX example, which is below here. Okay. So yeah, I've written some text here explaining what we're going to do, but let's just go through the code briefly together, and I'll try to explain the most critical parts for this. So the first part here is we import the NetworkX library because we want to use a NetworkX graph generator as our graph. So we define some parameters here, but then we make the call here to NetworkX, and we're going to create a graph with an algorithm called the stochastic block model. So it's not so important what this algorithm does, but it's quite interesting, and you can read up on it if you wish. But let's do that. So we're going to create this graph with NetworkX. The cell has executed. So now to visualize it, we can use the draw NetworkX method here to see what we actually got. So this is what we have. So just looking at this graph, I think that it kind of looks like there are 3 communities in this graph. One large, very dense community with a lot of interconnected nodes. Sort of the black lines here are edges, right? So if it's very black, it means that it's a very dense cluster of nodes here. And this also kind of looks like a community that is less dense. And this is also a community smaller than this one, but it's also quite dense, it looks like. So we have kind of eyeballed this graph now, and we think there are some communities there, but it's really not really, we cannot really trust our eyes, I think, on this. So if we want some mathematical precision on this, we could run an algorithm, a community detection algorithm, and see if there are indeed 3 communities. So that's what we're going to do now. So first, what we do, because we're going to use GDS to run this algorithm, we're going to load the NetworkX graph into GDS with this call. This is the call you need to use. And we're going to call it social network. Okay, so we can call like this. The call has executed. The progress bars here, I'm sorry, they're a little bit buggy to update in this notebook. I'm not sure why. But we can see that the node has actually loaded. It has a node count of 200, which looks about right, and about 6,000 relationships. So now that we have this graph in GDS, we can actually use an algorithm to analyze it. And since we're interested in doing community detection or cluster detection, we're going to use the Louvain algorithm, which has a very nice implementation in the GDS library. So I'm just going to call that now and then print the result. Indeed, it looks like this. So for each of the nodes, 200 nodes that are listed here, we have the IDs, and then we have a community ID for each node. This represents the community the node belongs to. But it's a little bit hard to see like all the different communities there are. We see the number 40 and 175 here. But if you want to see all the different numbers, all the unique numbers in this column, since this is a Pandas DataFrame backed by NumPy, we can just call unique on this column. So that's what we're going to do here. We can see that there are indeed 3 communities. That makes sense. That's what we saw here. But if you also want to see if this graphical image now, these regions actually map to the communities that we think it does, then we might want to color this graph, color the nodes according to what community they belong, and see if it matches our perception here. So I'm just going to do that now. First, I'm just going to generate a random color for each of the communities with a little dictionary comprehension here. So it's not so important how that works. But then we can use these colors and create a list of the colors for all of the nodes based on the communities that belong to. And then we can add these colors to the plot that we used above, and we get something like this. So here, indeed, you can see it looks kind of like, so it's kind of, maybe it's rotated image or something, or mirrored it, but it does look like I think the original communities that we identified before, that we have 3 of them. This is the less sparse one, this is the big dense one, and the smaller one that's also quite dense. And yeah, that's just an example of how you can use NetworkX to generate something, load it into Neo4j, analyze it, and then export whatever you want to as well. Right, so that's what I wanted to show here. I'm going to go back to my slides here. I also have some links for you to the covering the to the documentation and to the demo notebook, which has examples for all the other things I mentioned today as well. So you can have a look in your own time and think about this more thoroughly. And with that, I also want to thank you.